All right, hi you guys. Before you panic, I know this looks like a lot of stuff to copy down, but I just thought in order to save, I don't know, my handwriting looks a lot nicer if I don't try and write while I speak. So I have all the writing and the whole problem here copied down, but I'm going to go through step by step. So if I go too fast, then go ahead and pause and catch up. But this is a full write-up for, I'm at the bottom of page 10, by the way, in your chapter 8 packet. So almost towards the end. We have another means problem, so we're doing an estimation of a mean of something. And so in this case, we're doing a confidence interval since we're trying to estimate something. We've got a principal at a large high school claims that students spend at least 10 hours a week doing homework on average. To investigate the claim, AP Stats students, they decide to take a random sample, 250 students of the school. How long do you spend doing homework every week? And based on that one single sample of 250 students, the sample mean is 10.2, sample standard deviation 4.2, that's our x bar and our s sub x. And we have to construct and interpret a 95% confidence interval for the mean time based on just our one single sample that students at this school spent doing homework last week. So in this case, what we've got is we need to first start by stating and defining all of our stuff. So we're going to be using all these x values, and all these x values are what the students collected from their random sample. And each x value stands for number of hours spent doing homework per student each week. So it would not be a good thing to just write x equals number hours. You have to be a little bit more specific than that. Number of hours of what? And in this case, it's important to note this is each week for homework, not each day or each month or each weekend. So be as specific as you can. Be careful when you're defining your stuff. You don't want to get dinged or lose silly points for just lack of, being clear in what it is that you're studying. Our population here is students at this school, all students at this high school. And our opening sentence, we want to estimate the mu of x, and the x is defined up here, so it's okay to use mu of x, the mean number of hours spent on homework in a week. We want to estimate the mu of x. Sigma x is unknown, that's why we're using a t confidence interval, so make sure that whenever you're using a t interval, you're stating the reason you're doing that is because the sigma x is unknown. We are estimating it based on our sample standard deviation. As you remember, a t-distribution is a little bit different from a normal distribution. It has a similar shape, but the tails are fatter, and that's because we have a lot more error in our tails because of our estimation based on the sample standard deviation. We don't have the population standard deviation, we're just estimating it. That introduces a little bit of error into our work. And so, let's see, another thing to compare, I'm going to try and compare back to last section when we were doing proportions. So remember, for proportions, we don't use t's, we always use z's. That's a big difference between proportions and means. And I've said several times that you need to be really clear whether you're doing a proportions problem or a means problem, because that affects several things within our work. So there's our introduction sentence, and make sure that you have your conditions that are being checked here. For randomization, it does say we have a random sample of 250 students, so that is right up here. Just recopy whatever it is. I've said a bajillion times that you're not going to get credit on AP problems if you just say random check. To be a little bit more specific than that, remember, an AP exam is a chance to suck up and show off all the knowledge that you have and be super professional and eloquent in your writing. So we have a random sample of 250 students is better than just saying random check. Okay, independence condition, remember that's the sampling without replacement condition. So even though we probably did not sample our students and then put them back in the pile of students in order to be sampled again, we probably sampled without replacement, but as long as your sample is small enough, meaning not bigger than 10% of your population, and the way that we say that, then we can proceed. The way we say that is we take our sample size and multiply by 10, and that gives us 25 hundo students at this large high school, and it's probably a good idea to say, therefore, the 10% condition is met. Remember, I've told you that other textbooks use like a 5% condition or a other percent conditions based on the textbook. So you want it to be really clear what conditions it is that you're checking. Okay, for normality, in this case, remember when we're doing a proportions problem, you can do NP and N1 minus P. In this case, we don't have P's, so we can't do that. And we got to read through the wording of the question and see if it tells us that the population is approximately normally distributed. It doesn't say anything about that up here. Dang it. Okay, so next best scenario is that we can try and apply the CLT. And don't just say something about the CLT. These are just tips for you guys, but let's try and say something about the sample size being 250, which is bigger than or equal to 30. Therefore, the CLT applies. Therefore, it is safe to use T. So these are some really picky but important details that you need to have within your work. Again, you're trying to show off all the stats knowledge that you've gained to this random person that's going to be grading your AP test at the end of the year. Okay, so when the CLT applies, that means it's safe to use T. I would not say anything about the distribution being normal or a sampling distribution being normal, because remember, a T distribution isn't exactly normal. It's got a similar bell curve type of shape, but there's an important difference between the two, those really fat tails. So keep that in mind. I'm not saying anything about being normal here, so I'm not going to use like a normal inverse norm to come up with my Z star, because it's not a Z star, it's a T star. So just say safe to use T. Anyway, some statistics and things that we're going to write out to the side before we start plugging into our formula. Remember, the formula on the formula sheet is statistic plus or minus critical value times standard deviation of statistic. So our statistic here is our X bar. From the problem, it's the 10.2. That's the number of hours just from that sample, the average number of hours that students spent on homework last week. The T star, that is our critical value. It's our multiplier that helps us with our margin of error. Remember, for proportions, we use a Z star and you do inverse norm for proportions. When it's a T star, you do inverse T. And this is in your calculator. I highly encourage you to pause the video and crunch this number just to make sure you're okay getting this 1.9695. But that is inverse T 0.025, and that's because there's 2.5% on each tail. Because remember, we're doing a 95% confidence interval, so that means that the 95 goes in the middle and each tail has 2.5%. And then our degrees of freedom, remember that's n minus 1. The n is 250, it's the sample size. N minus 1 is 249. So this is what you type into inverse T, and that's what gives you 1.9695. The sample standard deviation is 4.2. Root n is 250. That all goes in, and then this is your interval that that gets spit out. Remember that you have an interval menu in your calculator. It's under F7 ints, and this is a one sample T interval, and so that's the T interval is what you're going to select in the calculator. And you can have the calculator spit out all of this information for you at once. You want to tell it that you want to input statistics because you already have the X bar and the SX, so it will just ask you for those, and it's also going to ask you for the degrees of freedom. When you crunch that, it will spit out this interval for you all at once, but as you know, showing all of this work is really, really important. This is where you get the majority of your points of credit for this problem. Your calculator might round these numbers just a little bit, but it's going to be really close, so it's going to give you a good idea of whether you have all of your numbers correct or not, okay? And so again, here's our interval, and remember what this interval is saying. We're estimating the true parameter, which is the total, or percent, which is the total number of hours by the entire school, which is a really difficult number to come by on our own. So we're just estimating that it is anywhere in here. We are not estimating it to be exactly 10.2 hours because you know that's just one sample. A second sample could be very different from that. So we are estimating it to be anywhere in this interval. It could be 9.7, it could be 10.6, it could be right smack dab in the middle. We don't know. We're just saying it is anywhere in there. Okay, our conclusion sentence is that we're 95% confident that it's 95 because that's the confidence level that was given to us in the question. And then state the context of the stuff. What is it we're trying to estimate? We're estimating the mean number of hours spent on homework each week by students at this high school. Just recopy the question, basically. Is between 9.677 and 10.723. When possible, when this is not a proportion, put the label, the units on there. This is in hours. Okay. Letter B is asking us, based on our interval, what can we conclude about the principal's claim? And so the principal claimed what? Let's go up and reread the problem. Principal claims students spend at least 10 hours per week doing homework. What do you guys think about that? Here's the interval we came up with. Is the principal lying? Is he true? We're not sure. Okay, so since the 10 hours is within our interval, that's what we're looking at here. He says it's at least 10 hours. And 10 hours and more than 10 hours definitely fits in our interval. So we have no reason to doubt his claim. We took one single sample, we based an interval on that, and according to our interval, yeah, he's telling the truth. Students are spending at least 10 hours a week on homework according to our interval. Okay? Remember that we're estimating that the mean is anywhere within this interval. And so even though our sample mean was 10.2, that's the exact middle of our interval because we plussed and minused our margin of error. But the 10 hours is also in our interval, and a lot of values that are higher than 10 hours are also in our interval. So we are saying that anywhere in that interval is the true parameter, this mean of all the students at this school. Okay? So there's just another example for you of means and how to go through the condition checks and how to show your work, and I reviewed some calculator stuff. So again, if you missed something, bring it up in class, or you can rewind the video, obviously. Maybe watch this video before the test too, just to brush up on what to do for the free response questions. But that's all. Big difference between proportions and means. There's a lot of little details there that you need to be careful of. Thanks for watching, you guys, and I'll see you tomorrow.